Hi, good evening, guys. Am I audible?
Yes, sir.
Okay, so already it's 7:06, so we'll start the session.
Yes, sir.
So today we will start with the connection design. So first we'll go through the theory part, and then we'll see some calculation part for each type of connection. So let's start with the connection. So what is the connection? Connections are structural elements. Those are used to connect the structural members with each other, like beam to column, then column to column, again beam to beam you can connect. So whatever element used to connect these members, it is called as structural connection element or connecting elements. So what are these connection elements typically? Those are clit angles, gusset, bolts, and welds. So all these four will make the will make two member join each other. So with the help of these members or these elements, we can join any two members or in any plane or in any direction. Okay. So what are the some tips to design the connections? Connections shall be designed in order to match with the design assumptions made while designing of the structure. So in case of steel structure, as we discussed during our base plate design, whatever assumptions we are making during the analysis, if we are considering the pin connection, then we have to detail it out as per the assumption, so that the pin connection will achieve, right? If it is fixed connection, then we have to detail out connection as a fixed connection, so that it will behave as a fix and it will carry some movement. So it is very much important whatever assumptions we made during this design. As per those assumptions, connection shall be designed or detailed out. When members are connected to web or flange of the connecting members, its capacity shall be checked to transfer the actual load coming. Right? Whenever we connect member some beam to column flange or beam to beam web, during that time the capacity of that flange or web shall be checked to transfer the actual load coming on the that flange or web. Bolts and welds shall be designed so that there will be ease of installation, fabrication, and access of welding. So, depending on the height of the structure or criticality of the structure, we have to provide such type of connections so that they will be easily uh, accessible, or we can easily install those connections. When we want to if the building height is 50 or 60 meter, so during that time providing welded connection for such a height, it will be a difficult. So rather than providing welding or welded joints, it is recommended to provide the bolted joint, because it is quite easy to provide bolted joints, and it requires when we work at high elevations, then we don't need to have a skilled labor just to tighten the bolt. But in case of welded connection, first thing, at such elevation, doing welding is quite difficult. Second thing, it will require skilled labor, so that there should not be any pocket in the weld, and the total weld capacity what is required will be achieved. So that's why, depending on the location of the structure, height of the structure, and importance of the structure, we have to decide what type of weld or what type of connection shall be provided. So whenever two types of fasteners are used to transfer the load, both the fasteners capacity shall be checked independently. So in case of shear connection or any connections, whenever some of the clit angles or gusset plate, those are welded to the member, connecting member, and other member will be bolted to that gusset plate. So in that case, we are using two fasteners. One is bolt and other is weld. So we have to check both the capacities. We have to check the bolt capacity as well and shear or weld capacity as well. And both shall be checked independently. There should not be a combination of its capacity. So if we are checking bolts for shear V, then for same shear V, the the weld shall be designed and checked. Okay. And these are some type of the connections. Here you can see this frame knee connection, where it can be called as movement connection with a haunch. In this case, it is top of the column where bolting is provided and haunch is provided to transfer the movement. This is column beam connection, similar to the movement connection. Only thing is that haunch is provided at the top. This is fixed base column. You can see the bolts are outside the flanges. So this is fixed base. This is pin column base in which the bolts are provided inside the flanges. This is pipe connection in which it will be welded to all pipe. In case of pipe connection, bolting is not possible. This is beam to column web connection. This is beam to beam web connection. Again, this is beam to beam flange connection. This is bracing connection. This is also bracing connection which will be used for truss. So this is a typical shear connection detail. Here you can see this is a gusset plate, minimum 10 thick provided. Two bolts are provided at a spacing of 70. Edge distance is provided 40 mm, and the first bolt location or the top of plate from the top of flange of the beam is 50 mm. So this is a typical connection, shear connection. And this gusset plate, as we are discussing, there are two fasteners. One is this bolt, and other is this plate will be welded to this beam at this location. It will be a fillet weld on both the sides. So when we design this bolt for the shear, the same shear shall be carried by the this weld also. The weld should have sufficient capacity to carry the shear what is carried by the bolt. Okay. So these are connection sketches or photos. These are the rivet connection. Now rivet connection are obsolete and we don't use rivet connection. Most of the rivet connection you can see on railway platforms. Most of the old structures were having this type of connections. This is latest connection type in which you can see these are the gusset. If you see this gusset is welded to this beam for top bracing. Also this gusset will be welded to this beam, and this end plate that will be welded to the this beam. So whole assembly will come along with this beam. So this beam will carry two gusset at top and bottom and end plate. So once this assembly comes on the side, it will be bolted here, and then later on these bracings will be connected through the bolt. So it is easier method and also good practice to use bolted connection because it provides flexibility, and also we can achieve the required connection type. If we provide welded connection, then there will be a some part of fixity will get developed, because of which there could be a transfer of movement, right? So this is completely welded connection. All members are welded. In India, most of the cases we follow the welded connection, and very few locations are there where we follow bolted connection. So this is welded and bolted, as we saw in last photo also. The gusset is welded to this member, this column, box column, and then it is bolted to the beam. So this is mixed type of connection. So mainly two fasteners are there, bolts and weld, for which we have to check the capacity. Now, what are the type of connections? First is shear connection. So when we connect beam with the column or with the other any beam with the bolts in the web, then it is called a shear connection. We are keeping flanges free and only connecting web with the column. So it is called a shear connection. Moment connection. In moment connection, we connect the top and bottom flanges with the flange of the column. Then it is movement connection. In that case, we provide some additional stiffeners so that the slenderness of the web shall be reduced, and also this gusset or these stiffeners will provide some support to the flange. So always keep in mind, movement connection is done in the major direction of the column. Movement connection will be always with the flange of the column. It will never, you can never find movement connection in the web of the column. It is always with the flange of the column. Then single plate angle connection, double web angle connection. So single plate angle connection means we'll have a single angle here, which is connected to the on one leg of that angle is connected to the web, and other leg of that angle connected to the column, and both the at one end it will be a welded connection, or leg will be welded, and on other side it will be a bolted. Double web connection, double web angle connection, it means this type of connection where in the web of the beam there are two angles, one angle on right side, one angle on the left side, and both these two angles are connected either through the bolt or through the weld. Top and seated angle connection. So in this case we have one angle at the top and another angle at the bottom. So this is called seat angle and this is top angle. So seat angle provides or seat angle helps for the erection. We can place this angle before erection, and we can just raise the beam during erection so that we can put bolts on the top seat angle, top angle. Then seated beam connection, it is same as this, only there will not be a top angle. It will be having only bottom angle which will support the beam, and it will have a bolting arrangement. So this is also a double angle bolt connection, where in this case beams are connected with the flange of the column with the angles and bolts. So type of member joining, one is beam to beam connection, beam to column flange connection, beam to column connection. So these are the typical connection. Sometimes you can find the splice connection. Column to column connection is also there, where we need to provide the splicing, or we can call it as a splice connection. Similarly, it will be there for the beam also, for beam splice or column splice. Now we'll see the first. We'll start with the bolted connection. So in bolted connection, grade of the bolt. So what is grade of the bolt? We have two to three grade of the bolts which we commonly used in the industry. The most commonly used is 4.6 grade, and the other is 8.8 grade. 4.6 grade is, you can say, this is the normal bolts, where its ultimate tensile strength of bolt is 400 and its yield strength is 240 MPa. So when we consider 4.6, or when we say grade of bolt is 4.6, what it denotes, this 4.6, for the first number 4, it denotes the ultimate tensile strength of the bolt material. Okay, so 400 is my ultimate tensile strength of the bolt, and this 6 denotes the its yield strength is 60% of ultimate tensile strength. So what if we consider this 400 is ultimate tensile strength, its 60% is my yield strength of the bolt. So it is 240 MPa, right? In case of 8.8 grade, so 8 is my 8 stands for ultimate tensile strength in multiple of 100. So that is 800 is my ultimate tensile strength of the bolt, and its 80% will be my yield strength of the bolt. So 8 to 8 is 64. So 640 MPa is my yield strength. Similarly, we have 10.2, in which 1000 is the uh, ultimate tensile strength of the bolt, and 20% of it is the yield strength. So this, just keep in mind what these numbers denote: grade 4.6, grade 8.8. Now spacing of the bolts. The minimum spacing of bolt shall be 2.5 times the nominal diameter of the bolt. Right? If bolt diameter is 20 mm, then minimum spacing shall be 50 mm. It should not be less than that. And maximum spacing of bolt shall not exceed 32 T or 300, whichever is less. In this case, T is the thickness of the thinner connecting material. It may be either web of the section or gusset plate, whichever is less. So that into 32 or 300, whichever is less, that should be the maximum spacing between the bolts. Now minimum edge distance for the bolts. The minimum edge distance is 1.7 of hole diameter for sheared edge, right? Sometimes we do cutting of the section on the side. So in that case, the edge of the section will not be a flat, or it will not be a in like it will not be a like machine cut. So in that case, we have to provide some additional edge distance so that it is considered as 1.7 times of the hole diameter. So if hole diameter is 22, so 1.7 of 22 should be the edge distance, and 1.5 for the machine cut. When we order section from the factory, it will be a machine cut, so it will have flat edges. So in that case, we can consider the edge distance of 1.5. Okay. So as per our IS code, there are some nominal bolt diameter and the oversize hole or size of the hole requirement is there. So if our bolt diameter is between 12 to 14 mm, then standard clearance hole or standard clearance in diameter and width of the slot, if it is 12 to 14, the hole size will be just 1 mm higher than the bolt diameter. So for 14 mm of the bolt, the hole diameter will be 15 mm. For 16 to 22, it will be more by 2 mm. So for 16 dia bolt, it will be 18. For 20 dia, it will be 22. And for 22, it will be 2. And larger than 24, it will be 3. So if the bolt diameter is of 30 mm, then hole will be of 33 mm. So slightly oversized clearance in diameter. In that case, the hole diameter will be slightly oversized, so that so this can be considered as bearing type bolts, in which bolt diameter is 12 mm and its hole diameter is 15 mm, right? So for 16 to 22 it is 4, 24 it is 6, and larger than 24 it is 8 mm. So when we want to provide a slotted hole, sometime uh, during analysis we release some ends, right? Because we don't want to transfer forces to the other structure. When two structures are connecting perpendicular to each other, during that time we don't want to transfer the loading of one structure to the other structure. In that case, we have to provide the slotted holes. So how we can achieve that condition in the stat just by releasing the ends, right? We can release fx so that axial force will not get transferred to the other structure, but achieving that condition in the field can be done by providing the slotted hole. So slotted hole in the direction of the force. If you want to release the axial force, then slotted hole in the direction of axis of the member can release the forces. So in that, for that purpose, these slotted holes are there. So for 12 to 14, this short slot, it is 4 mm, 16 to 22 6, 24 for 8, and more than 24 it is 10 mm, and for long slot it is 2.5 times of the bolt diameter, right? So with this we can achieve the slotted condition, and also we can release the forces. Then type of bolts. There are two types of bolts. One is bearing type bolts and other is high strength friction grip bolts. Right. So we'll see the what is bearing type bolt and high strength bolt. Bearing type bolts means the bolts are tightened, not tightened fully or too completely. When the bolt and the connecting plate slide, and when the bolts are getting beared against the any edge of the uh, plate or wave of the section, then the load will be transferred by the bearing of bolt and plate. So that type of bolt is called bearing type bolt. Let me check. I have one video on I saw one video on YouTube. Just let me know if you hear the voice.
Two plates that's our connections, and we said
Is it audible?
Yes, sir.
Okay. So just watch this video for a few minutes.
So in a very tight connection, I'll give you an example here. I have a 3/4 inch bolt through a standard size hole, and I have this long slotted hole here. In a very tight connection, we're relying upon the bolt to transmit the force. So you can see as long as the bolt's between the two plate elements, when I try to pull on them, the connection doesn't slide anywhere. And so no matter how tight I tension this bolt, it doesn't matter even if it's not fully tightened, the connection is still together and it's passing the force from one to the other. That's what we mean by a bearing type.
Okay. So as seen in this video, you can see that the holes are slightly oversized, bolts are placed, and nut is tightened, but it is not tightened completely. And when there will be a slide between the two surfaces, so this can be a one of the beam, and this can be a your gusset plate. So when there is a slide between the plates, the bolts are getting beared against the surface of the plate or the web. So by that bearing, or due to that resistance, the load is getting transferred to the other member.
Because this angle member is bearing on the bolt, which the bolt is then transmitting the force to this other, the angle member on the right. All right, so that is what's meant by a bearing type connection. Now, we want to talk about a slip critical connection. So in a slip critical connection, rather than putting our bolt at the end here, I want to say what happens if we put the bolt in the middle. Well, if it's not tightened, then it'll slide. So that's what's meant by slip. So in a slip critical connection, we don't want that slip to occur. So the way that we're going to prevent that from happening is by tightening this bolt. So you have to think that as we tighten the bolt is being put into tension. And as you keep twisting the nut, that bolt continues to build up tension, which is basically clamping these two plates together. That'll give us some sort of friction force between the two elements, so that when we have them apart and we try to pull on them, slide doesn't occur. So in a slip critical connection, you transmit the force from one member to the other using just the friction force between the two plates that's developed by tensioning this bolt.
So the other type, what he has explained, it is a high strength friction type bolt, in which the bolts are tightened so that the bolts will be under tension, right? So bolt will be under tension, and whatever force transmission will be there, that will be by the friction between these two plates. So tightening of the bolt will have some uh, perfection. We need some perfection, because their bolt has some capacity of taking pre-tensioning. So depending on that requirement, there are certain type of washers designed to tighten the bolts. So this is a slip critical connection, in which we are not allowing slip to occur. We are not allowing sliding of the plate occur. And in first case, we are allowing slip of the plates, so that the bolts are getting beared against one of the surface. Then it will transfer forces to the other surface. So this is the basic difference between these two type of bolts. One is bearing type bolt, and other is high strength friction grip bolts. So in this case, we tighten the bolt to certain friction, to certain tension level, so that there will be a friction between the two plates. Okay, so type of bolts clear. You can watch this video. I'll just put a link of this video in chat message box. I'll just put this link. You can watch later on in detail. Okay, then shear failure. So there are two type of shear failure. One is single shear failure, other is double shear failure. So when two surfaces are there and there is only one shearing plane, in that case the bolts are going under single shear, right? Only this surface is going under single shear. When we have a two plate, or when we have a sandwich plate between two plates, in that case we have a two shearing surface. One is at this junction and another is at this junction. So in this case we have a double shear of the bolts. In this case we have a single shear of the bolt. So in double shear of the bolt, we more area of bolt is getting sheared, so its capacity gets double. In case of single shear, the capacity is less. So say double shear bolts will have a higher capacity because two areas are getting sheared off. So bolted, so design strength of bearing type of bolt. So first is effective area of bolt under shear, right? So bolt should satisfy VSB is equal to VDB. So VSB is the factored shear force. This is the force which is generated during the analysis. Once you apply all the loadings and all combination, then there will be some force in the member. This is that VSB. Then VDB is the design strength of bolt, which shall be smaller of shear capacity of bolt or bearing capacity of the bolt. So this VDB is calculated or can be decided based on two uh, criteria. One is based on the shear capacity of bolt and other is bearing capacity of the bolt. So first we'll see shear capacity of the bolts. So how to get shear capacity of the bolt? Shear capacity of the bolt is we got it by nominal shear capacity of bolt divided by factor of safety, right? So factor of safety for the bolt. So we have this factor of safety in our IS code. It is 1.25 for bolts, and VNSB. This is the nominal shear capacity of the bolt. Then how we can calculate this nominal shear capacity of bolt? It is calculated by ultimate tensile strength of the bolt divided by root 3 into NN into ANB plus NS into ASB. So what is ANN? NN is the number of shear planes through threads, right? Number of shear planes through threads, and NS is the number of shear planes intercepting non-threaded portion of the shank. If you have seen the bolt has some threads at the bottom, right? And as you go up, the threads are uh, there are no threads, and the shank area or the bolt area is completely plain area. It don't have any threads. So when we consider the net capacity, we have to check the shear plane where it is actually occurring, right? I'll just draw a sketch. So if this is my bolt, it will have some threads like this up to this level. So what this NN is? NN is number of shear planes through threads. So if I am having one plate somewhere here like this and other plate somewhat like this, right? In this case, one surface area is going through the shear plane which is falling under the threaded zone. So this portion is falling under shear zone. So for this case, NN will be 1. right? Nn will be 1. So number of shear planes through threads. So number of shear plane, how much shear planes are passing through threads? It is one number. So one for each bolt. So it is always one number of shear plane always pass through the threads. Now ns is the number of shear plane intercepting non-threaded portion. So in case if I have another plate like this, in that case this is the second area which is passing through the non-threaded portion. So that is ns. So it is ns number of shear plane intercepting non-threaded portion of the shank. So in this case it is 1. So as soon as I put another plate, the bolts are going under double shear, right? One plane at this location, another plane at this location. So it is going under double shear. So for double shear bolts, this ns is always 1, and if it is a single shear, it is always 0, right? Because we have nn over there, and there will be no ns when the bolts are going under one-way shear. When it is going under two-way shear, uh, in that case we will have one ns and another nn. Okay, so based on this we can decide whether nn is 1 or ns is 1 or nn1 and ns 0. Now ANB and ASB. ASB is nominal shank area of the bolt. So nominal shank area of the bolt means this area where there are no threads. So it is a complete area available for the shear, and ANB is the net shear area in threaded portion. So net shear area in threaded portion. So in this case, due to threads, the total area is getting reduced. So this area and this area will have some difference. So this is the complete area available, whereas due to threads, the total area got reduced. So that area is almost, we can say, 20% is getting reduced due to the threads. So we can consider 78 or 80% of the complete area as a net area in a threaded portion. So once we got these areas, we can decide the nominal bearing capacity of the bolts, right? So we got the shear capacity of bolts. Then we have to calculate the bearing capacity of the bolt. So how we can get the bearing capacity? So bearing capacity can be calculated by V dPb is equal to VNPb divided by factor of safety gamma NB. So nominal bearing strength of bolt is calculated by 2.5 into kb into d into t into fe. So what are these terms? Kb is the smaller of. So bearing it depends on uh, what conditions. One is edge distance, then pitch and yield strength of the bolt and plate, right? Why it is depending on edge distance and pitch between the bolts? If the edge distance is very less, then the plate will be easily teared out. Before failure of bolt, the plate will fail, right? When it is bearing against the plate surface, before the failure of the bolts, the bolt the plate will fail. So that's why this edge distance, it is governing on the edge distance. Another thing is distance between the pitch. If the two holes are very close to each other, in that case also, before failure of bolts, the area available between the two holes will get deformed and failure could occur. Then ultimate strength of the bolt to the ultimate strength of the plate, it depends on the grade of the bolt. If high strength bolt are there and if mild steel plate is there, then plate will fail first. So based on this kb factor is determined. So smaller of all these terms will be considered for calculation of the nominal bearing strength of the bolt. D is the diameter of the hole, because we are calculating the bearing against the plate, so we have to consider the diameter of the hole and not the bolt. T is the thickness of the thinner part, whichever is thinner part. Like either thickness of the web or thickness of the plate, and Fu is the ultimate tensile strength of the plate, not bolt, ultimate tensile strength of the plate. So based on this, we will get the VNPB or nominal bearing strength of the bolt. This will be divided by factor of safety to get the design bearing capacity of the bolt. So we got two values for the shear. One is by shear capacity of the bolts and another bearing capacity of the bolts. So minimum of these two capacities will be considered as shear capacity of the bolt. Are you getting this, or any query up to this?
No, sir.
Okay. Then we will see the tension capacity of the bolt. So tension capacity of the bolt is its nominal tensile capacity of the bolt calculated by zero point 0.9 into FUB into AN. So 0.9 FUB is the ultimate tensile strength of the bolt into net area. So net area is the net tensile stress area as specified in the appropriate Indian code. For bolts where the tensile stress area is not defined, AN shall be taken as the area at the bottom of the threads. So why at the bottom of the threads? When there will be a tension in the bolt before failure of the shank area, because we have more area available there, there will be a failure at the location of threaded portion where the shearing edge is there. Due to tension, that threaded part or that threaded portion will yield first. So that's why we are considering the net area, and that should be less than yield stress of the bolt into shank area. This is the shank area of the bolt and multiplied by the factor of safety. So this is tensile tension capacity of the bolts. Now, how to check the bolts, whether those bolts are sufficient or not? We have to work out the interaction ratio of combined shear and tension. So same bolts we are using for the shear as well as for the tension. So we have to check the combined capacity of the bolts, whether they are capable to take the shear and tension simultaneously. So that can be checked by VSB divided by VDB, means actual shear force divided by the design shear capacity, its square, plus factor tensile force acting on the bolt or the tension in the bolt coming due to the analysis divided by its tension capacity and its square. So the addition of these two equations should be less than 1, so that the bolts are sufficient to carry the shear force and axial force simultaneously. So this is how we can check the bolts, right? So this is about the bearing type of bolts. In case of high strength friction grip bolt, in case of high strength friction grip bolts, we are just transferring the force through the friction between the plates. As we have seen in the video, we have to transfer the force through the friction between the plates. So how we can transfer? We have to tighten the bolt up to such an extent that there will be a no slip between the plates. So that's why it is called as a slip critical connection. When we consider slip critical connection, always we provide a high strength friction grip bolts. So in case of slip critical connection, nominal shear capacity of bolt is governed by slip friction type connection, and this friction capacity is calculated by this friction coefficient into number of effective surfaces or interface offering frictional resistance. KH is the fasteners in clearance hole, means what type of holes we have provided, and FO is the proof stress or how much tension we want to develop in the bolt. So that is the value of this FO. So based on this factor, we'll get the nominal shear capacity of the bolts. Now friction coefficient is 0.55 for steel to steel. Then number of effective interface depending on whether it is a single shear type connection or a double shear type connection. If it is a single, then NC will be 1, and if it is double shear, then NC will be 2. KH 1 for the fasteners in clearance hole, 0.85 for the fastener in oversized and short slotted holes, and zero point 0.7 for the long slotted holes. So if you provide long slotted holes, then there will be a less resistance, so we can reduce the force up to 30%. So these are the factor of safety gamma MF 1.1 if slip resistance is designed at service load, and 1.25 if slip resistance is designed at ultimate load. So it says that whenever we use service load combinations, so load combination without any factor, in that case the factor of safety shall be 1.1, and when we use the factor of ultimate load combination or strength load combination or combination with the factored load, in that case we have to follow the factor of safety as 1.25. Then F0 is the minimum bolt tension at installation. So F0 is the minimum tension in the bolt, or how much tension we should allow in the bolt. That is the proof stress, and that tension will be at the time of installation, and that will be calculated by A and B into F0. A and B is the net area of bolt at threads into proof stress is its 70% of ultimate tensile strength of the bolts. So that will give us the F0 or tension in the bolts, based on which we can calculate the nominal shear capacity of the bolt. So this is, by this we'll get the, so in this case there is only one shear capacity of the bolt. In case of bearing type bolt, we were having two type of capacities. One is shear capacity, other is bearing capacity. In this case, since it is only a friction type of bolt, or the load is getting transferred through the friction, not through the bearing, so we have just calculated the capacity of the bolt. So there will not be any bearing capacity of the bolts. There will be tension capacity. That tension capacity will be same as bearing type of bolts, that total net area into zero point 0.9 into ultimate strength of the bolts. So for high strength bolt we got the tensile capacity as well as shear capacity of the bolt. So again, for that, for this also we have to calculate the combined shear and tension interaction ratio. That should be less than 1, so that bolts are sufficient to carry the tension and shear simultaneously. Okay. What are the failure of the bolts? Shear failure, bearing failure of bolt or plates, tensile failure of bolts, and tensile failure of the plate. So shear failure of bolts when the plate having very high axial load. In that case, the plates are getting sheared off. Plates slides against each other, and bolt is getting sheared off at shearing edge. So this is shear failure of bolt. This is shear failure of the plate. This is bearing failure of the bolt. In that case, the bolts area is getting reduced, or the area bolts are getting yielded due to the bearing of the bolts against the plate. Bearing failure of the plate, in this case, if the plate is grade of the plate is weak as compared to the bolt, then plate edges are getting yielded compared to the bolt. This is tensile failure of the bolt, in which the bolts are get elongated up to their yield strength, and after that they fail, or they fail in tension. This is bending failure of the bolts. The bolts are getting bent between the two surface, and this is tensile failure of the plate. So because of pull out or pull in axial forces in the plates are getting teared off at the hole location, because of the net area is getting reduced whenever we drill or we add any hole in the plates. So these are the common type of failure of the plates and bolts. Now, bolted connections, shear failure of bolts, bearing failure. What we want to check in bolted connection: shear failure of bolts, bearing failure of bolts, bearing failure of the plate. So one of the bolts are bearing. Once the bolts are bearing, the connection will behave linearly until yielding take place at one or more of the following positions. So whenever we apply a load for bearing type bolts, in that case the load will start transferring from the bolts to the plate, right? It will start from bolts, from one plate to the bolt, and from bolt to the other plate. So it will behave linearly until the yielding of one of the element occur, either at the net section of the plate, okay, under combined tension and flexure, or on the bolt shear plane, or in bearing between the bolt and side of the hole. So any one of the condition will occur before failure of the connection, right? So tensile failure of the plate. How we can calculate the tensile failure? So tensile failure is zero point 0.9 into Fu into An. Fu is the ultimate tensile strength of the bolt, and An is the net area of the plate available for the to carry the tension. So when we have a tension in the plates, right? If we consider this location, the area between the two whole rows, in that case, we have a complete area of the plate. So there is no failure will occur. So failure will not occur at this location. But if we consider at a section A, in that case, the total area available for the plate to carry the tension is this total width into thickness of plate minus all this hole diameter. So my net area is getting reduced at this location. That's why the plate may fail at this junction rather than failing at somewhere this location. So net area will be calculated by total width minus n into dh, that is n into diameter of the hole into thickness of the plate. So that will give me the net area available to carry the tension. So that net area will considered here, and that will give us the tensile capacity of the plate. If this load is more than this capacity, then we can say that there will be a tensile failure of the plate, right? So what are the advantages and disadvantages of the bolted connections? So bolted connection is required, manpower is less because it is just a matter of tightening of the bolt. So manpower is not that much required. So because of high strength bolts, strength is more as compared to the rivet connection. So this is compared to the rivet connection. So we cannot now consider this as an advantage. But when in the old days, when we started doing bolted connection, because of high strength bolts, we reduced the number of bolts. So it was more economical, or providing more strength as compared to the same number of the rivets. Erection of structure more fast with use of the bolts, because all the bolt holes are drilled in the shop, and all the elements are just brought to the site, and they are just erected and tightened with the bolt. So erection is much faster than the welded connections. This is a cold process, hence no additional stresses in connecting members. In case of welded joint, we heat the members so that there will be a fusion between the members, and uh, connection will occur through that fusion. But there is, due to that, there is a continuous heating and cooling of the members. So because of that, there could be a local stresses, temperature stresses getting generated. The the most important advantage is bolts can be removed, replaced, and retightened in case of faulty bolting or due to any failure. So since steel is a ductile material, before failure of any part, it will give us some warning, right? It will show some deflection or yielding of the bolt or members, so that we can remove those bolts, we can change the member size, we can retighten those bolts. So all possibilities are there, so that to rectify that failure. But in case of welded, it will not be a possible. We have to cut the member and trim the joint, so that we can make it another section. So this is the one of the most advantages, that we can remove or replace bolts anytime. What are the disadvantages? Architectural look for weld connection. Architectural look compared to the weld connection is not that much good. Weld connection can provide a good architectural look. Bolt connection has a less strength as compared to the weld connection, as the net area is getting reduced due to provision of holes. Since we drill number of holes in the member for connecting or providing the bolt, so its net area is getting reduced. So it is having less strength, overall less strength as compared to the weld type connections. In case of vibration load, bolt strength get reduced because of loosening of the bolt. When there is a vibration, continuous force, or same force is acting continuously, because of that, the bolts are getting loosened, and it will reduce the strength of the connections. So for vibration, we have to check whether the bolts are sufficient tighten or not, or maybe we can use the high strength type bolts. So for this bolt connection, any queries up to this? Any queries on bolted connections? Am I audible? Okay, so we'll just start with the welded connections. Welded connections. So first we'll see advantage and disadvantages. So what are the advantages? So as there are no holes required for axial strength of the welded connection, so its capacity is more as compared to the bolted connection. Less connecting elements, hence lightweight connections. In case of bolted connection, bolts self-weight itself is quite high compared to the gusset plate, so it is quite heavy joint connection. Welder connection looks good as compared to the heavy bolted connection. If you see heavy bolted connection, there are number of bolts, and it doesn't give good appearance as well. So, but welded connection has some more disadvantages compared to the bolted connection. Welded joints are brittle, hence their fatigue strength is less. Welded joints are quite brittle, like they will not give you any warning or any sign of failure. They will just fail immediately due to the, and hence it is not good for the fatigue design. This is a hot process, hence there could be a development of additional temperature stresses in the members. Skilled labor required, because if there is any pocket remain in the weld, then its capacity will get reduced. So skilled labor is required. Then no provision for expansion and contraction joint, or difficult to achieve slotted connection. As we achieve a slotted connection in case of bolted connection, in case of welded connection, it is difficult to achieve the slotted connections. Then inspection of weld is difficult. Inspection of weld is difficult at higher elevation, because sometimes we need uh, this sometimes we need a radiography test to check whether the weld is correctly done or not, but it is difficult to perform at a higher elevation. Hence it is not recommended to have a welded connections. Just a moment. So these are the advantages of welded connections. So this weld connection, I think we'll see in the next session, tomorrow's session. So if you have any doubts on the bolted connection, just let me know. So we can discuss a little bit on more on that. In next session, we'll complete this weld connection remaining part, and then we'll see some examples. Any queries so far? No queries?
No, sir.
Okay. Okay, then so we'll stop here, and tomorrow we'll go through the welded connection because it is more, and I think we will not be able to cover in this session. So we'll keep another session tomorrow. Then we'll have welded connection and some connection design we'll see, and then probably in the last lecture we'll see the gantry girder design. Okay, so probably another max to max 3 lectures are pending. So if you have any queries on the topic what we have discussed till date, so you can list down, and in last session we will discuss those queries.
Okay, sir.
Okay. In meanwhile, you can go through the video for which of which link I have already posted in the message box. So you can go through the video, so you will be better understanding of bearing type bolt and friction type bolts.
Okay, sir.
Okay, so good night everyone. We'll see you again tomorrow.
Good
Same.
night, sir.
Good night. Good night everyone.
Good night, sir. Thank you.
Hold on, sir.